So excited here today to talk about Precision Ag on the Fieldwork podcast. We have a couple guests Skyping in, joining here today. We got Michael Ganschow is a farmer in Illinois, and Dr. Raj Khosla is a professor out at Colorado State. Michael, how about you first? Thanks for joining us. Give us a little background on you.
Yeah, absolutely. Thanks for having me on, guys. So I'm a sixth generation farmer. Live in Walnut, Illinois. Our farm's just outside of Walnut, Illinois, which is located in Bureau County. I graduated from the University of Illinois in 2007. I worked in the retail field for just a short time and started farming full-time with my dad. In the fall of 2008, we farm about 3,000 acres, corn and soybeans, and then we use cover crops in the wintertime.
Raj, why don't you give us a little bit of a background on you? As Mitchell said, you're a professor out at Colorado State. Why don't you give us a background on what it is you do out there?
Okay, thank you, Mitchell and Zach, for having me join you guys for this podcast. I'm a professor at CSU now for the last 20 years, and my entire career has been in the development of precision agriculture. The focus of my lab is on precision nutrient management, primarily nitrogen, but we use a lot of development of techniques to classify fields into management zones. My lab was among the very first ones that received funding from USDA and NASA. This was in year 1999 to help understand spatial variability in soils. And so something that my lab is known fairly well is for quantifying spatial variability in soils. And that work led to the development of management zones and how do we manage nitrogen across these zones. Fast forward, more recently, we have been working with both nitrogen management as well as water management. How do we apply the right amount of water at the right time, place, and amount? And throughout this journey, we have employed a whole suite of sensors and developed algorithms for these sensors to help us make better management decisions.
So taking what we heard there from Raj and some of the work that he's been doing at the university in his labs there, and you bring that kind of back to the farm. Michael, you're a farmer out in Illinois. You have been utilizing a lot of technology out on your farm personally. Why don't you talk a little bit about some of the stuff that, kind of what Raj has done and relating that to what you're doing on your farm?
Yeah, so over the last couple of years, actually, we've started integrating more of those management practices into our own farm, and most of it takes place on the nitrogen side of things. A majority of our nitrogen that gets applied on our farm gets applied as a side dress, and what I do is we plan all our fields using variable rate technology, and the reason why we do that is because we have such variability throughout most of the fields that we farm. You've got higher organic matter areas and low organic matter areas, and our sand and clays, and so the need to do that is more important on the stuff that we farm compared to maybe some other things or some other farms that are just down the road. And so what I do is I actually write variable rate prescriptions when I plant my crop, and I take those planting prescriptions after Dad has planted the field or I planted the field, and I transform them into prescriptions for my nitrogen application so that my nitrogen application is mimicking my seeding rates. In other words, I'm applying less nitrogen in areas with less seeds, and I'm applying more nitrogen in areas with more seeds. And we've really started to see an increase in our nitrogen use efficiency and really our bottom line as well. And it's not necessarily a sense of, we're saving money because we're not applying less nutrients in poorer areas, but we're taking advantage of the yield gain and the better producing ground that has the ability to take those extra nutrients and produce more bushels.
So, Raj, when you're talking about having remote sensors out there, do you have remote sensors that are on the farms, actually with the farmers, working with real farmers' data, or are these sensors that you have more in place on, say, your test sites?
So this has been a journey for our program here. If you look back, what we had 20 years back, we primarily had to rely on satellite imagery. And we're talking about visible wave bands, red, green, and blue, and the near infrared. or sometimes we would deploy an airborne imagery to acquire the same data. But if you look at what has happened in the last 10 or 12 years, now we have access to those same suite of sensors, which could be tractor mounted or handheld. When you refer to remote sensors, by definition, remote sensing is acquisition of information of an object of interest without being in contact. Mm-hmm. And so in today's agronomy or commercial world, there's a whole suite of sensors that are available to help farmers make management decisions. Now, I've said this in my papers and in my talks that I believe technology is ahead of science.
I was just saying the technology is ahead of the science, that the robots are taking over the world.
Skynet is becoming aware?
Yes.
Is that the deal?
That's exactly what it is.
Yeah, that is an interesting point, though. Interesting way to put that and to think about that.
Well, just that the tech is there, we can collect the information, but doesn't mean that we know how to use it.
Right.
I think that's what it means, that we can collect that information, but then it takes machine learning and whatnot to figure out what do I actually do with it to drive the outcome that's actually going to be able to help us out on the farm.
That's right. Let's jump back to Michael here for a minute. Michael, when I'm looking at your notes here, I can see that you use a lot of technology on your farm, and Raj works a lot with nitrogen. He's got a lot of sensors out there. I'm interested to hear his take on this as well, but a question I have for you as a farmer is, how accurate do you feel that the nitrogen management stuff is that you work with? I mean, how much do you really trust it on your farm? What do you think you've seen?
That's a really good question.
Well, some of the things that we've used in the past, and I'm not going to be specific on it, obviously, because I don't want to give anybody a black eye, but it's really been hard to quantify, and when they first came out with it, I mean, some of the stuff was really, really way off, and it was recommending way more nitrogen than what stuff needed. Now, that being said, that was kind of the first round of it. It's gotten better every year. I still think it's still a moving target, and a lot of it has to depend on the weather, and sadly, we just can't 100% predict that weather all the time, and that really changes what would have been good one year when you should have applied. So I think moving forward, as this becomes more refined, that we'll get a lot better at that. We're just not 100% there on the technology for the nitrogen predictors and what you have left and all that stuff as of today, I feel.
Yeah, but Michael, you're mostly talking there about some of these big ag tools and the modeling systems, not necessarily like sampling or sensors and that kind of stuff, right?
No, I'm just talking the broad spectrum, the ag technologies out there. Now, if you go out to tissue testing and all that kind of thing, that's a whole different ballgame. But at the same time, you need to regularly do that, every week, because that tissue sample is just a shot, in time. And that's one thing that you've got to continue to do throughout your growing season. And it's really, really tough to get that done on every single field and be as precise as what you would want to be. But there have been some success stories using those kind of practices in the past to do that better job. It's just right now we need to have the workforce available to try to do some of those things, and to allow us to do it better.
Well, I think that's exactly back to what Raj said, that the technology is there, that I can get the data that I want.
Right.
But the science to make it super practical, that still might be some of the piece that's missing. But Michael, how are you addressing that now to still help you to make the best decision that you have the capability of doing?
It's just, mixing in different things, whether it be, tissue sampling, trying to use some of the nitrogen predictors. And mostly a lot of it has to do with using the data that we're collecting, like through soil sampling or through yield data. And, a lot of the applications that we're making, as far as nitrogen is concerned, we're making it when the crop is growing. So trying to attack it that way and not trying to front load everything up all at once, making multiple applications or split applicating some things to kind of adjust to what the weather has given you a little bit, and taking all that information, working together to kind of make it happen. That's what we're trying to do right now to address things on our own farm.
So instead of being a mind reader, you're a corn reader.
I don't know about that. I still think it's always kind of a moving target. I mean, nitrogen is a very funny element. It's a constantly ebb and flow almost, it seems like, to a degree. But we're trying to do the best we can with the information that we have. So
I'd go with corn whisperer.
Oh,
Yeah, that's a
That
little
sounds
bit.
that sounds much cleaner and nicer. I like that.
Yeah,
So,
yeah. You can. I'll let you use that.
there you go.
Raj, in your opinion, now, I'm not sure how much work you've actually done with the available to us management tools. Obviously, you're working in the lab. I mean, you're understanding the real data behind what's going on with that nitrogen. But what's your opinion on, maybe not just how reliable your data is, but the commercially available management tools that have become available to farmers now? What's your opinion of those and how accurate those might be?
Another very good question, and I think Michael is exactly right in that we don't have a commercially available diagnostic sensor for nitrogen. We don't. There are a lot of sensors available in the market, but these are all surrogate measures that gives you a flavor of nitrogen, if you may. For example, they're, without referencing a particular sensor, they pick up a signature from the crop canopy or from the soil, which is then translated into an index. One of them, which is very widely reported, is NDVI, Normalized Difference Vegetative Index. Now, it gives you the greenness in the plant. Greenness in the plant is not only related to nitrogen. It's a sum total of so many other stresses, biotic as well as abiotic stresses in the plant that can lead to reduction in the greenness of the plant. Now, most of the time we assume that it's related to nitrogen, and so you can fix it with nitrogen, but that's not entirely true. So as we continue to develop technology, we need to have a diagnostic sensor. And let me make a clarification what I mean by that. You and I can go to a physician and they can draw a sample of blood and can quantitatively tell you blood sugar level using a sensor.
mm-hmm.
But we're not there yet when it comes to nitrogen, phosphorus, potassium, or suite of other nutrients. We don't have diagnostic sensors commercially available in the market. They're in the pipeline, but we're not there yet. So that's one aspect. If you want to add something, go ahead.
Well, I was just saying, I think those sensors are really what's going to blow this stuff up, and it's going to get it really interesting, especially as those sensors are communicating with the diagnostic tools, or like the application tools, the big ag tech platforms and whatnot, to dial in those predictions and utilize weather technology along with the sensing technology, along with the outcomes. Michael, like you're collecting on your farm, Zach and I are collecting on our farms. I think the sensors are going to be really interesting. And right now we're seeing the first wave of that, I think, in the soil with the smart farmers, just looking at organic matter, moisture, temperature. There are some other ones coming. Raj, like you said, you probably know way more of them than I do, but I'm seeing there's some stuff that's in very initial build coming from Iowa State. So that'll be interesting to see what they can come up with. They're doing some real-time nitrate sensors that would go on the equipment, just like the smart farm does. I think that'll be interesting. But still, it boils back down to then what do I do with the information? It's training that machine learning. It's training the system to work for us. So, Michael, what do you think would be, in your experience, how do we work towards getting there? How do we implement?
Well, actually, while we're having this conversation, I was thinking about a video actually I saw today. I was at a John Deere equipment meeting, and they were showing this video of the technology that is really coming down the pipeline, and they're showing better weather predictors, and they're showing having sensors in your field to know when you have deficiency in any type of nutrient, and then it makes a recommendation as to what you should apply to fix those kind of deficiencies. I think down the pipeline, that's where we're headed. I mean, that's gonna be a reality. I'm gonna be getting a text, within a single field telling me, hey, I have a phosphorus deficiency that I need to address using this product, and that's how I can do that. So going forward, how do we do that? I mean, the technology, I guess, isn't 100% there yet, but waiting for that to come out to allow us to do our job better, more efficiently, and to be better stewards with our nutrients, for me is super exciting.
We have a couple guests Skyping in, joining here today. We got Michael Ganschow is a farmer in Illinois, and Dr. Raj Khosla is a professor out at Colorado State.
Michael, why don't you talk a little bit about, how farmers can implement this into their farms on their own, the way that you have been able to do, and really working with that so that we can get this done on our own, take a look at what we're doing and really concentrate on what we're doing so that hopefully we don't have to deal with government regulations coming at us. Because as a farmer myself, for sure I know, and I'm sure Mitchell and I'm sure we'd rather get this done on our own and manage it on our farm rather than having the men and women in the suits come and tell us how we're supposed to be doing it.
No, absolutely. The thing about regulation is we know that if regulation were to come in, it's going to be kind of all encompassing. And we know, from our experience as farmers, that you can't just throw one management practice and say, you have to do this or you have to implement this, and this is going to be a blanket coverage on all farms. So no, absolutely. We need to be proactive about this. And that really means taking each individual farm and farmer and trying to do things every year to improve what you've been doing in the past. As I always tell guys, if you can take one thing that you've been doing and change it to make yourself more efficient for the next year, then that's going to add into it. But a lot of it, Zach, is really at the end of the day, we have to show progress. Obviously, the biggest problems that we're seeing right now is, stuff in some of these bigger lakes. You got the Gulf of Mexico issue. And what we're trying to do here in Illinois, as much as possible, is to just show progress. So, if that's by trying to get guys on board with implementing the 4Rs or trying to implement cover crops or doing some of these edge of field practices like, bioreactors or saturated buffers or, anything that we can do to help solve this problem and show progress is what we need to do right now. And that's kind of our goal here, like I said, in Illinois through the Illinois Nutrient Loss Reduction Strategy. We're trying to show that progress. And as of right now, we've been fairly successful in trying to do that. Sometimes I wonder if it's going to be quick enough to appease the problem, long term, because it's one of those things that this problem didn't happen overnight. We can't fix it overnight, and I hate to say it, but it's going to take time to make it better. And sadly, I don't think we have enough time required to make that progress at times, So,
well, I think you're right, that we've got to show that we're making progress, but we got to be able to show that we're making results, though, too. So
right.
when
at the end of the day, it comes down to solving the problem. You have to have the results to go with it. Exactly.
Yeah, and I think now we're seeing the ability to work and get there. Now we've really got to implement and take some drastic action to do it. When we're airing this, a lot of guys are probably going to be out in the field side dressing and whatnot and doing field work. So Raj, to kind of pull this stuff together, what do those guys need to be thinking about? What do we need to be thinking about as we're out in our fields during this growing season in order to continue to do things better and move the needle?
That's an exciting question, of course. Number one, we need to always take a stock on variability. How large are they looking at the variability? The scale of variability is number one. Number two, what's causing that variability? Is that something a farmer can manage? Does the farmer have the resources to manage that? And I think those three are very closely related questions that our precision agronomist must always have it on the forefront. Quantifying that variability out in the field, looking at what is the scale. A scale could be looking at last year's data. What was the variability in the grain yield, the final product? Did it go from 30 bushel to 300 bushel, like I see it every year in irrigated corn in Colorado? Or did it go from 175 bushel to 225 bushels?
I think that's a good way to look at it too, that we're not just looking at where is it at right now versus where we want it to be, like I think we often do with precision ag, but what is the variance out there in the field and understanding why. Why is it so variable? Why in part of our field am I raising only that 175 bushel yield, or that would be a crop failure for Michael, but 175 bushel, but
it might be nowadays. Yeah.
you know, so but why is it doing that? And then why is other parts of the field yielding well over 300 bushel? So it's identifying that variance and managing based on that, I think, is an interesting way to put it. And now we've got the tech coming out to quantify that variance even more specifically than what we had done before.
So it's very common. I've seen field that shows 1,000% variability. When you look at 30 bushel to 300 bushel, that's 1,000% variability. And you're exactly right. We need to find out what's causing that. Can we fix it? And do we have the resources to do that? And I want to circle back really quick on what we were talking about previously. So assume, fast forward, we have the sensors that allow us to accurately quantify distribution of nitrates in soil or distribution of nitrogen available in the plant. But one thing we must remember, there's another challenge that we need to overcome. And that challenge is collecting data at spatially dependent scales. Meaning, if you have a sensor that can quantify soil moisture in your field, but you can only afford one sensor, what good would that be? Because if you're basing your decision with a variable rate irrigation system with only one sensor, you're not doing precision ag.
Right.
And so to be able to collect data at spatially dependent scales, meaning you will have to distribute these sensors in the field at very high data density scales. And that would be a limitation right now. So what I'm getting at is that we don't only need these sensors, but we also need these sensors to be highly inexpensive to be able to distribute them out in the field at spatially dependent scales so that Michael can then translate that information into his applicator and make a real-time or near real-time decision on the go when he's applying side dressing.
Well, and hopefully, Raj, that's exciting for you and what you've been able to accomplish over the last 20 years of evaluating that variance and evaluating zones. Then we can deploy the sensors out there in those zones, so we're at least dialing in some of the variability without just putting out those sensors based only on, say, soil type or different yielding areas and whatnot. We can be very specific with where we want to use those zones. So I think a really good discussion, to evaluate that variance and then collect the data to help us to understand the variance.
Speaking of variance, I've got another question that deals with, Raj, I want to know your opinion on the accuracy of some of these on-the-go measurement tools where they'll read the soil or the plants on the go, as you're actually applying, whether it's nitrogen or seeding. Do you think, are those tools accurate right now, or can we just not process data quickly enough that's accurate enough to really depend on those tools to be able to do that?
That's, as a precision agronomist, my best choice of answer to that question is it depends, right?
Yep.
So I think that's a loaded question there. I can't just give you a blanket answer, what is the accuracy of multiple tools that are available right now. One thing we need to look at, and Michael would be a better person to attest to that, is that we are more accurate today than we were 2 years back.
And hopefully we'll be more accurate 2 years from now.
100%.
Exactly.
Yeah.
Right. And so, yes, we are on the right trajectory. However, as a farmer, when you are, all of a sudden inundated with so many choice of tools and you don't know what the science is behind those tools, whether they will fit well into your operation or not, that's a very tricky question. And I wonder how Michael goes around in choosing what to embrace this year or how slowly to make changes to his operation. I would be very interested in hearing him.
Yeah, I think that's a really good way to be able to kind of get us working towards the end here on how do we dig through all this? Because like we said, there's so many different options available. Yeah, Michael, walk through us how you did that on your farm.
Yeah, I think that's one of the biggest challenges right now in agriculture is trying to sift through what is good and what is not. I mean, there's, as Zach can attest to too, there is no shortage of the amount of technology that you can add to anything or utilize on your own farm. And usually what I try to do is I start small, or I choose something. And usually a lot of times, you can try something at a pretty minimal cost. And a lot of it's just trial and error. And working with it on your own farm and seeing what you like and what you don't like and what works and what doesn't work. So it's not necessarily just choosing one direction and going with it and just using it forever. On my end, it really deals with a lot of trial and error, and a lot of that starts with the relationship that I have built with my retailers over the years. I've got guys that I know and I trust that they will recommend good things for me to use, and that's usually where I start. That doesn't mean that I am opposed to trying something outside the box that I don't have a relationship with somebody. But generally speaking, these things start with somebody that you know and trust that has proven to show good information and good things that have worked on your own farm. And so those are usually the platforms that I go to. But if I can see an economic advantage or help me be better with my application rates or the tools that I use on my own farm, I'm not opposed to going that way. But long and the short of it, it's a lot of trial and error at times. So what do you think, Zach? What do you do? What are you doing on your farm?
I mean, I would say exactly the same what you've said there. It's trial and error. It comes down to, it always comes down to cost, and trying to figure out whether you can actually get a return on the investment on that technology or not. And sometimes you'll throw money at a certain technology really just to see if it works, because you know that there's probably a future in that. But really, like you say, there is no shortage of technology coming at us right now. It's just trying to figure out what's useful and what is not, and what's practical. What can we make work, and what do we just flat out not have the time or the resources for right now?
In order to improve our impact on water quality, on environmental stewardship, there's way more than just one way to be able to do it. And we can utilize a lot of different precision ag tools. It boils back down to utilizing our inputs effectively to produce a good quality crop that's done in a sustainable manner. So I really appreciate, that discussion. I think this fits in really well with what we've been discussing. Michael, then Raj, any last takeaways on this stuff, and how do we keep the conversation going with you? Where can we go for more information?
At least in Illinois right now, there's a lot of available tools right now, and a lot of research being done on this issue right now. I work with the Illinois NREC, and we support a lot of research trials for trying to get a handle on this nutrient problem, whether it be using precision technology or a lot of different things. So, I mean, the Illinois Farm Bureau is always a really good resource. But honestly, there's a lot of retailers out there with a lot of really good information too. It's always, at the end of the day, sifting down through what is good and what isn't. But I think if it were me, I would probably start at the Farm Bureau level. They've got a lot of really good information on these type of things as well. So.
Raj, what about you? Kind of final takeaways, final thoughts here as we wrap up, and where can people find you for more information with what you're doing?
Sure. So one thing I want to emphasize is that precision agriculture is new. It is still in this stage of infancy. And I know some days it feels like that we are building an airplane and flying at the same time. I feel the pain. I am part of the journey as well. We have been farming for thousands of years, but precision ag has been around for only 25, 30 years. And that's one aspect. And we need to be careful when these sensors do arrive that we're hoping industry is building for us. What do we do with the data? So it's not only going forward would be farming the land, but it would also about farming the data. How do we translate data into new knowledge by developing algorithms so that we can make a decision and farmers can act on that decision to make our agriculture more productive, more efficient, more profitable, and more sustainable?
I think
we have a lot of work cut out for us, for all of us.
Yeah, so we had Michael Ganschow and Raj Khosla joining us today via Skype, so we appreciate you guys being on the Fieldwork podcast with us today.
Well, thank you guys. It was awesome to be a part of it, and I appreciate you guys having me on the show.
Thank you. It was great to talk with you.
Thank you, guys. Appreciate it.